few words about the organizer. Yeah, it's Scholar IT Solutions is an IT solutions provider based in the US. It has a lot of expertise, and they have a robust team which serves all over the US. It's one of the best company to work for and work with in the US. You can follow Scholar IT Solutions in Facebook, Instagram, Twitter, and everything, and you can get more updates and knowledge sharing sessions and more offers. The team is planning to expand in the future, so following these pages and everything will be really useful to you for your career and everything. And a little bit about me. And I'm a consultant, expert in modern technology, and I work in a lot of different fields. And majority of the things is business development and digital transformation, as in transforming all the traditional businesses into using technology as their main way of operating. And in my free time, I like to mentor and advise people who are younger and looking for seeking guidance. Okay, so let's start with artificial intelligence. So what is artificial intelligence? So intelligence itself is something which is measured in various ways in nature and in humans. So human beings are capable of higher order of intelligence. We are different from animals, and our intellect has led us far into what we are right now. So why do we need artificial intelligence in this case? Because artificial intelligence is here to work instead of us. That's the shortest way you can describe artificial intelligence. And also, at the rate which technology has taken over the world and everything like that, there is not enough humans to actually serve a lot of people. For example, a company who is has 1,000 customers or 1,000,000 customers, but only 100 or 1,000 people who are serving them in terms of customer service. It's impossible, because customer queries are they're coming in so fast, and they cannot handle such a huge volume with such a short amount of people. And you can't expand it to getting 1 lakh people to serve 1 lakh people. That would be practically not viable. So that's where artificial intelligence comes in, because modern technology and everything requires much more assistance from computers than we think, because technology itself has become overly complicated, and we need stuff like this to make our work simpler, make our work effective and everything. So basically what we are doing is we are copying something which is naturally given to us, intelligence, and we are implementing that inside a computer. So what we do is, let's just say you are a person, you are identifying 2 colors, and which is blue and which is red. So you're doing that because you are able to see that there's a color difference in there, but a computer cannot do that. So you need to teach it how to do it, or you need to program it how to do it. So that is pretty much artificial intelligence in a nutshell. This field itself is so vast, and I don't think I have enough time to cover it entirely. So I've not covered artificial intelligence in depth in this thing, because it is meant of something like an introduction to the whole field. And I've covered some main places where artificial intelligence can be a big game changer, and there's a lot of opportunities in there. And yeah, there is so much in artificial intelligence apart from this slide. So just this disclaimer before we start doing things. And let's move on. Okay, so artificial intelligence is an umbrella term. There's so many sub things in that, and this Venn diagram shows how this is related with the other fields. So artificial intelligence itself, I'll just call it AI from now. It's too big. Okay, AI itself is has the main subsets is machine learning and deep learning. We'll talk about that in detail in the later slides. And the related technologies to this field, the main ones are data science, data analytics, and big data. So all of them pretty much are data. Big data is ways of organizing and storing and retrieving large amounts of data. Why is big data required when we have actual databases and everything? Because right now itself, when I'm talking here, I'm generating millions of data bytes and everything like that. The amount of people using technology has increased by a huge margin, 10,000% in the last 10 years. And So more and more data is being collected. As we speak, there are being so many data centers being built. So many data has been collected. A single day alone, so many people use Instagram, Facebook, and everything, and they keep on creating photographs, uploads, images, everything like that. So traditional or conventional methods cannot be used to store such huge amount of data. So that's why we need big data. And when big data comes, also we need something to analyze and find out what's there in that data. That is like what data science is all about. And data analytics is like a something between both of these two things, where you actually represent what you learn from data science into something which is more usable. So apart from this, data science and data is very important for artificial intelligence, mainly because it provides the kind of data or samples which we need to get started in many of these artificial intelligence methods and everything. So what is machine learning? Okay, so data centers, like I said, they are being built everywhere and everything. And as we speak, so many amount of data is being created. And why I'm saying that is the amount of data collected is so huge that it's humanly impossible to do it. So we need artificial intelligence. Okay, so coming back to the main topic. So what is machine learning? Machine learning is one of the main fields in artificial intelligence. So this is how we actually implement so many different models. The majority of the topic I'm going to talk is there in this slide alone, because it's a vast topic. I could talk about machine learning for an entire day. There is so many topics in that, so many subtopics in that, and this is just scratching the surface, introduction to all these things. So there are three types: unsupervised learning, supervised learning, and reinforcement learning. So the main thing which most people use is supervised learning, because that's why ML engineers are trained. The people who are working in machine learning, they're called as ML engineers. They're responsible for now creating machine learning models, both unsupervised, supervised, and reinforced. So the main majority of the thing is like either unsupervised or supervised, mostly supervised. So supervised as in it requires human intervention. So for example, let's just say you're differentiating between a cat and a mouse. That's a classification problem. So you have an image and you know which is a cat and which is a mouse. You just have to make the computer do that. So for example, a cat has whiskers, a mouse has whiskers as well. Now that becomes a problem, because the computer will say both are cats because both have whiskers. So you can't differentiate a cat and a mouse based on whiskers. So what will you do? Like eyes. Okay, cat's eyes are different, mouse eyes are different. Or a single, okay, let's just say the image which you have of a cat, the cat's eyes are small. Maybe it's a baby cat. So then it becomes another problem to classify that image. You don't know if it is a cat or a mouse. So that is all how the classifications work. So image classification is one of the common things. You have to classify something which is based on color, like fruits or vegetables or something like that. So what are the practical things why we need classification? Because so many people are uploading a large amount of data into the internet, and sometimes people upload offensive content or something which is not permitted for social sharing or anything like that, obscene content or violent content or something, and we don't have enough people to screen them. Early on, Facebook or anybody, they relied on complaints. User makes complaints that this is offensive, or they actually come across something which is offensive while they're searching for something based on some kind of algorithms. So a large amount of manual people was required to actually find out these kind of posts and delete them before they do any harm. But it wasn't possible when the user base exploded. Like there are so many users now. So many users are doing all these kind of things, and it's not possible for humans to actually sit and classify all these things. So that's why we have these machine learning classification algorithms. Apart from that, it's also used to do a lot of different things. Like for example, customer retention. So it has to figure out which customers are more likely to come back to you, and give them more offers or some kind of reasons to stay with your company or anything. And it's also used in a lot of medical diagnostics as well. Like differentiating from let's just say that there's a normal tumor, and then the thing is, the benign tumor is something which is harmless. It will be there, but it won't do anything. A malignant tumor is something which will be there, but it will be very harmful. And an expert doctor who's been trained for years and years is required to differentiate between both of them, because both of them kind of look the same for a normal person's eyes. To analyze that and bring that into like to a proper conclusion, it requires an expert who's at least 10 years, 15 years experience. So what we do is we hire that doctor as a consultant, and we analyze the difference between the two tumors, and we teach that to the computer so it can do it accurately. So more people are diagnosed properly and in short time and as early as possible without a help of a doctor being there. So that is why we need supervised learning. We have to, it's pretty much like you have a little kid and you're raising it, you're teaching it how to do things from your own knowledge. What makes a cat, what makes a dog. So like let's just say you have a kid, you're just asking the kids like, hey, that is a dog because it looks like this. You have to, it has these characteristics. It has these kind of attributes. And this is a cat. It has claws. Be careful of the claws. It has a lot of fur compared to a dog. And that again becomes a problem. Sometimes cat has less fur and dog has more fur. So these are the things that complicate the whole thing into like having advanced algorithms and rules to actually separate and classify all these things. So supervised learning is just training like a computer baby to like, know real world. And you are required there because you are the one who are supposed to train that baby into knowing what the world is, how everything is there and everything. So far what I've talked about is like classification problems, classification algorithms and everything like that. So the next kind of main algorithm is regression. So there are other kind of subtopics as well, but I'm just covering the main ones. Okay, so what is regression? So regression is something like, finding out that how two things are related. For example, a person who's smoking has less life expectancy because he's smoking, his lungs are doing this kind of things and everything. A person who's stressed a lot has less life expectancy. And for example, market forecasting, like, two things are related. Like, for example, when the temperature increases, pressure decreases or something like that. I'm not sure that's, right or wrong, but yeah, something, two variables when are related. So when we have to find all those things, we use regression. How to find out like which variable is like related to which variable. So if the winds are heavy, the rain is less. So if the winds are low, the rain is more. So these two things are kind of related, and we have to find out like stuff like that using regression algorithms. And it is used in a lot of different kind of things, like mostly forecasting, coming up with values which we could use as a reference. For example, a politician might want to know like what kind of based on his campaign and his popularity and everything, he might want to know like, hey, I'm popular in social media. How much of that will get actually converted into votes? So he can find something like that. And the applications are practically endless. That's why there's like so many opportunities in artificial intelligence. You can apply it to anywhere. Yeah. So there is a lot more topics. If you're really interested in supervised learning or any of the other topics, you can Google them. It will be endless. And these are only certain of the use cases which are actually given on the internet. And so, okay, moving on to unsupervised learning. So unsupervised learning, as the name suggests, it does not require human intervention. You just have to build models. You don't have to actually teach or do anything. So what unsupervised learning is mostly used to do is find out clusters of data or reduce the number of data sets to make it easy to work with. So the first thing is clustering. So what clustering does is it actually classifies, not classifies, clusters. Like for example, of them are so these kind of things, it doesn't really need you to actually say which is which, because based on the values and variables, for example, customer buying behavior or how often the customer logs into Facebook. So a person logs into Facebook daily, he is a regular customer. If he walks in only in weekends, he is a seasonal customer or like, irregular customer. And if he doesn't log in at all, he only comes here to just sell products or something like that, then he is an unpredictable customer. You don't know when he's going to come next. So you have to separate all these data into different segments. So that's when clustering comes in. It's usually most in business, where you need target and marketing, recommendation-based systems, and customer segmentation. You want to know which customer is most likely to buy your stuff and how much of your product will actually get sold based on that. So clustering is one of those. And the next thing is dimensionality reduction. So when unsupervised learning comes, sometimes there is so many data sets, so many categories. For example, have you seen somebody who is posting in Twitter and Instagram? They have a huge amount of tags. They pretty much tag anything, whether it's relevant or irrelevant. So when the computer automatically starts gathering all this data, the computer doesn't know, and it just collects all the data, and you end up having a lot of data sets, so many sets, and then most of which are not required. For example, there will be let's just say collecting data from social media. There is a category called dog, and there will be another category called dog, like DOGG, or doggy, or something. So our pup or pupper or whatever. So all these things are people terms used. So dog, doggy, pup, pupper. All these four denote the same thing. It's a video about some dog, but it will be in different categories, and that makes it complicated for us to use that data. So what happens in dimensionality reduction is it gets rid of all these unwanted categories and groups those categories together. So it's actually easier for us to work with. So in that, a lot of things is there, again, to discover like different kind of data sets, how, if both data sets are the same, or if systems, as in, for example, all these other things they have done in it's almost like ready-made. You actually make them learn and implement them. But reinforcement learning is a bit different there. And for example, robotics. So a robot does make decisions based on the environment it is in, and that is unpredictable to greater extent. For example, let's just say you are put a robot in your rooftop. You don't know when it will rain or when it will thing, or anything might happen. All the unpredictable things can happen when you go into the real world like that. And a robot is actually going to go into real world situations where anything can happen. Let's just say you're having a robot to explore deep sea, and you say that there are no sharks over there, so the robot can be this size, and the robot will not be like eaten by a shark. But you can't say for 100% sure that there won't be a shark. Let's just say a shark from a nearby ocean for some reason came in here. So it has to be ready for that, those kind of situations, to make decisions, to know that this kind of situation is a danger or anything like that. And most of the time, the decisions and everything like that is made on real time in a very fast pace. And for this, supervised learning and unsupervised learning, they have a different set of libraries, and reinforcement learning is mostly done in video games, robots, aeroplanes, electric cars, or anything that interacts with the environment, which is unpredictable. And environment has so many variables: the wind speed, the temperature, the humidity, everything. So reinforcement learning is needed for that. And even in video games, reinforcement learning is used a lot. For example, if you're playing a shooting game with zombies, and you will get bored because the zombies behave the same way over and over again. So what you do is you make them into reinforced learning agents. So what these agents do, intelligent agents as they're called. So what they do is they learn from your behavior. Let's just say you're shooting always to the left. They'll know that you'll always shoot to the left. That's your attacking move or something. So the next time you come across the zombie or anything like that, will actually, anticipate that you're shooting to left and dodge it exactly, posing you a challenge. So that's how these agents work. Intelligent agents, they can make decisions on spot based on the input from the environment. In both supervised and unsupervised learning, you're giving input based on data, which you already have collected from users or databases or anything. In reinforcement learning, all the input is given live by the environment, the user, the actions, everything, and the response is also immediate. For example, in supervised and unsupervised, you can collect data and you can use it in the future because it's no rush. But in reinforcement learning, most of the applications are like how you collect data, input, process, output, just like a computer. So it's mostly used in robotics, video games, and where you have to quickly respond to all these situations, anything that has to interact with the environment specifically. So those are the basic types and methodologies in artificial intelligence. Machine learning. Let's move on to the next topic. Okay, so there's another type of learning in artificial intelligence, that is deep learning. So the difference between machine learning and deep learning is very simple, and deep learning itself is kind of not that complicated compared to machine learning. So if you see there's a lot of different kind of flowchart kind of things. So if the input is a car, this is a decision tree based on all these conditions, which is the computer learned over time with data. It decides if it's a car or not. These variables and the weather and all these kind of things. But in terms of deep learning, all these rules are predefined. So what you do is, a car has 4 wheels. A car has this attribute, a car has that attribute. You predefine all these kind of things, and then you extract the data from the input, and you run it through all these conditions, and you can use that to predict if it's a car or not. So the difference is very simple. A machine learning is something which is learning based on data, the real-time input, or clustering and all those techniques. And deep learning, it's always based on a set of rules defined by the user. So deep learning requires more input from the engineer compared to the machine learning, because machine learning, the input is actually from data or external source. And deep learning is mostly useful in one important, very, very important field, which is medical and health, where you have to be really accurate in diagnosing a disease or monitoring a condition of a person to quickly say things and everything. So deep learning models, yeah, they are like, how do you say, already a set of rules is there, and you just have to implement that. And there's a lot of rules to be implemented. It's not easy to come up with all those rules. And it's more structured compared to machine learning, which is predicting based on different kind of situations. Deep learning is more structured in the way, like it's more like judging a person. Okay, Industry 4.0. So if you people haven't heard of the Industrial Revolution, is how we got here in the first place. Rapid development and mass manufacturing, and using machines and everything to aid humans. It started with Industry 1, the first industrial revolution, where they used steam power. So around the early 1860s, 18 things, everything was powered with steam engines, steam trains, everything like that. So what is steam? You just burn coal, and the steam was used to drive everything. So the driving factor in that was steam, to push any kind of technology to work. And then electricity was invented. So then electricity was the main thing. Lots of power lines were set up, and mass productions were used, assembly lines. So in first age, it was kind of slow to do things in industrial way. The second age, it was faster. Assembly lines, assembling things in a conveyor belt and everything like that. It made it faster. And Industry 3, the third revolution, is where we are already there, where we are using automated production using computers, systems, and robotics and everything. And if you search for videos of how your mobile phone or solar panels or everything is manufactured, you will notice that human beings have very less to do. already in that. They only check if it's right or wrong. And most of the time, the human intervention is mostly required for maintenance of the robots, production systems, and IT systems, and in quality checking. And Industry 4.0 is upon us. So why are we talking about industrial revolutions? Because Industry 4.0 is going to change everything. Every time an industrial revolution occurs, they term it as a revolution because revolution, everything changes. First, it came from steam to electrical, then from electrical to computers. And then now, the fourth revolution, everything will be automated. Even the kind of things which are not automated right now will be automated for sure. Internet of Things, machine learning, artificial intelligence, all these topics are very important now. And there is a huge boom coming up ahead in the next 10, 15 years. And that is why we are in dire need of artificial intelligence engineers. Yeah, and in Industry 4.0, all the fields I mentioned here, Internet of Things, cybersecurity, cloud computing, manufacturing, augmented reality, everything has like so many job openings. Every single field is really important. And if you notice that in the future, we need more engineers, designers, and teachers, because these kind of three jobs are not likely to be replaced. So in the last 5 years, there has been a lot of debate about what kind of jobs will be replaced by artificial intelligence and what kind of jobs are being safe to actually not replace. So designers, engineers, and teachers. Teachers, as in it covers everything. People who educating and everything like that. The way the people educate other people will differ. Like, we have online learning now, e-learning and everything like that. It will change, but it will not go away. And design as well. We haven't reached a level where designers can be replaced by artificial intelligence, because the amount of knowledge and depth of field of study required for designers is not technically possible right now. Maybe in the near future after 2050 or something, but right now it's not possible. Okay, and so the next thing is engineers. Engineers have to build systems. And if you notice, the engineering boom itself in the last 100 years was there because of industrial revolutions. And every industrial revolution always has a need for engineers. Different kind of engineers, yes, but engineers are definitely required. Okay, now I'm going to talk about applications of AI, and the list is not exhaustive, as in this is not the entire list. So I took this image because it has the most important fields as of now. So let me just go through one by one. Healthcare. So in healthcare, the role of AI is in diagnosing mainly. There is a field in machine learning called computer vision, which is used to analyze patterns, medical images, photographs, everything like that. And that is very important to analyze these medical images or something. There's a separate topic in that called image processing, which is heavily important in healthcare alone. And automobile industry. Right now we have electric cars coming up. Electric cars are incredibly simple, but they have a lot of technology behind them. In fact, they use multiple technologies and everything. And the main technology here in automobiles is Internet of Things. So Internet of Things, where every kind of information or everything is connected to the internet. So if everything is connected to the internet, to automatically guide all these things, we need AI. And finance, I'll talk about in detail, so I'll leave it now. Surveillance. So the amount of people or customers or everywhere, it's increasing, both offline and online. There are still people who are using, gathering in large events, gathering in large malls everywhere. People are social people, and they're not likely to settle down inside the house for a long time unless we have corona, like how it's right now. But it's going to change in the future. Corona is not going to last forever. So when people come out, we need surveillance, and it's impossible. For the past 30 years, the surveillance is done by manually humans. People sit and watch each and every video with their own eyes. Can you believe that? You sit and watch the recorded video, or they actually see the live video to see if somebody's intruding or somebody's doing something or anything like that. But right now we have image detection tracking algorithms, and we can actually find out who is being a harmful person or something. Let's just say in a road, everybody is walking in different speeds, and suddenly one person is running at high speed. So we can track that person separately, and we can actually analyze that to understand if he's robbing or he's being chased or is a crime being committed, and we can give appropriate response to the police or something like that. Or sometimes you can find out like if people are disobeying the rules because there is no police or there's no less people or something like that. Yeah, social media, I think I've explained it before. There is so much of content being uploaded into social media, and there is very less way to sort out. So you have to use artificial intelligence. Entertainment. The entertainment, how it's useful is, in this day and age, before a week, one episode is all was required to be produced, because people are busy with their work. They don't have access to television, or TVs are expensive, the connection is expensive, like that. But right now, we have to produce at least 10 episodes per day. That is quite impossible is like a huge field that Dubai has opened an entire university dedicated to just artificial intelligence, just to artificial intelligence, each having its own department and specialization. Almost every college has BSc artificial intelligence, BTech artificial intelligence, everything now. And that is why, I mean, the reason is that it's almost there in every single field, and the amount of fields that AI will invade will just increase. It won't decrease. Space exploration. All in this day and age, before in 1970s, everything only government organizations used to explore space. So it was limited to government funding. Only government can actually have that much money to fund and do space. But now space is open for the private people. Like if you notice, like Jeff Bezos, the owner of Amazon, is planning to go to space, and Elon Musk as well, he's planning to go to space. These people are very rich, and they are private. They're not part of the government. Before, like ISRO or NASA can only go there. Now they opened up to the private. Everybody can go there, and they want to colonize Mars. So in this planet itself, we have like so many work to do. And if they're going to colonize the moon or Mars, anywhere, it is going to be a lot of problems. And when a lot of problems are there, we need a lot of solutions, obviously. And gaming itself, I already explained, to make the game more immersive. People these days, they get bored easily from playing too much, and they require constant amount of new content that is practically impossible to create with humans alone. In most of the fields I've explained, artificial intelligence does not replace humans yet. It actually helps them. We haven't reached a way of technology where we can entirely replace everything with robots or AI, but that thing is not that far away. Maybe in the next 20 years, everything will be replaced. But right now, AI is actually assisting in humans in doing every single thing. Like in business, chatbots are there where you can actually talk with a person. I mean, talk with a AI, and you won't realize that you're talking with a computer and not a person, because some of the chatbots are so advanced that they use something called natural language processing. They understand the way you talk, and they respond properly. And every time a person comes and talks, the AI understands. It stores the data and uses it to learn, understands the pattern in which they're talking, and it understands what they want to do in that, what they mean when they say certain things, regional kind of things which only certain people talk about, everything. And robotics I've told about already. And agriculture itself, is booming mainly because the amount of population increase. These days, lifespan, medical technology, everything is given to, like, people living for longer, and people, the population is increasing tenfold, and we need a lot of food produce. So we need to use AI in agriculture to enhance humans working there, helping them to, like, properly manage all these things using robotics, sensors, Internet of Things, to find out which is the best temperature, how much of a water is required, because water is only 3% or 4% of the entire Earth's water is actually usable. Everything else is salt water. So water is an important resource, and we have to, manage it properly. If a plant requires just 10 liters of water per month, it's always best to give only 10 liters of water per month. And that kind of accuracy is not there in a human. Only a computer can do that. And e-commerce is, yeah, mostly recommender systems, customer retention, which you already talked about. And okay, so I've been talking about a lot about theory, and this I would take about 5-6 minutes to actually talk about how this is all implemented. And as everything in computer science, you need to be a programmer to work in artificial intelligence. So it's an essential skill. Without being a programmer, you cannot do proper AI. So the main thing is, like, there are many systems, and there's another kind of revolution going on in the back end to bring in non-programmers, like that. It's called no-code revolution, where you can actually do something in coding without actually coding, and that is called visual scripting, where you actually set things using flowcharts or some other methods like that. And it's actually much more complicated than coding. It's always easier to, like, sit and code instead of learning such advanced systems each and every single time. So if you're serious about artificial intelligence, you definitely have to pick up one of the programming languages or the other. In general, the programming languages are very similar. Some of them are very similar, like C family languages, C#, C++, C are very similar. And the other kind of languages like Python, interpreted languages are similar. And there's JavaScript for the web. And if you understand programming, what is it at the core? One programming language, if you learn, you can pretty much learn everything else, because they have a lot of similarities between them, even though there are a lot of differences as well. So you definitely have to pick up a programming language if you're serious about getting a career in AI. Python is a good option because most people find Python easy to get into, easy to work with, without all those fuss about rules and restrictions. And more advanced things like robotics or something, hardware in the sense always requires some kind of language in the C family, not C#, C or C++, because they're lightweight, they're extremely fast. Python is very slow, so they're mostly used for data science, machine learning, and unsupervised learning, all this deep learning and everything. So in terms of hardware, you already have to use some kind of thing like C or C++, because they're fast, they're reliable, and they're very memory efficient as well. So without learning a programming language, you cannot do artificial intelligence at all. And even if you find a way to do it, it will not be the best way to do it. Coming to job opportunities, robotic scientist, big data engineer, business intelligence developer, data scientist, product manager, ML engineer, research scientist. So all these things are kind of the top jobs trending right now. And this list is just starting. A lot of people are joining. In this year alone, artificial intelligence has, like, seen record number of people interested to learn, and enrollments are increasing tenfold as well. So new jobs will be created. The more and more people are ready to work in artificial intelligence, the more and more people will be ready to hire them, because the scope is pretty much endless for the next 15 years. So if you're picking up artificial intelligence as a career choice, it is a very, very good career choice to do at this time. For the next 15 years, you are guaranteed a job, almost 90% chance that you get a job if you do learn artificial intelligence properly. And each of these jobs kind of different. Like, for example, robotic scientist requires a different kind of learning technique, which we discussed earlier. And big data engineer requires, more analysis. Intelligence developer requires more intelligent agents. Data scientist, again, it is more collecting data and segmenting them. Product manager is making sure that your product is reaching the audience. ML engineer is one of the most important jobs. Almost every field or every company is almost hiring ML engineers the most. AI research scientists, robotic scientists are kind of lesser because right now robotic revolution has not happened yet. Unless they can find a cheaper method to bring robotics to the mass audience. Right now, very few people are actually using robotics at full thing. Unless they can have cheaper method to bring robotics in, the jobs will not increase. But in the next 10 years, that's set to change. So ML engineer, data scientist, data engineer, intelligent agent developer, all these things are very, very booming right now. If you are like willing to go for these roles, you're highly likely to get a job in one company or the other. And yeah, smart cities. So I have to talk about smart cities because this is the future. Almost every city or every urban settlement in the future is actually going to be a smart city or connected to the internet or smart in some other way. Japan is leading the revolution by making entire Tokyo digital with the most advanced smart city plan, and even rural cities in India have been selected for the smart city plan through the smart city program in India. And this brings in more and more requirement for engineers. And there is a lot of different things in a smart city, from technology to mobility, like electric cars, environment, shopping. So the growth we've achieved is always damaging the environment. And smart city is actually, like, when you say smart, it means you're efficiently using the resources without doing much or any damage to the environment. So if we are going to harm the environment with our development and everything like that, it's going to lead to a lot of problems in the future. So that is one of the main concern of which is almost every country now, because they've damaged the environment so much to come to this point where in some places like Delhi, for instance, the air pollution is really high. It could go to unlivable situations. And in Bangalore, the urbanization has gone to worse levels where the traffic and everything has become unmanageable. The people have been the city has been developed a lot, but the infrastructure was not developed as much. So these kind of errors are not people learn, the rest of the nation learns from that. That's the same thing for when you don't plan things in the proper way and things get in the way. So there is a huge requirement of engineers in almost every different field, from electrical to artificial intelligence to computer science, everything. Okay, some of the important things I saved for last. Fintech. So like everything, finance, financial services, currencies, we have cryptocurrencies now. Everything is going to be changed into digital. And there is a reason why I chose digital transformation and business services, because almost every single business will have to evolve into a digital company or a digital business, or else they die. It's simple as that. If they don't evolve into a digital company or a digital entity, the same for finance as well. They are more into numbers and all these things and not technology. So knowledge of both of these things, if you have it, you should definitely go for fintech because the opportunities are endless. Every single thing, globalization, cryptocurrency, interplanetary exploration, everything is related to fintech in one way or the other. It's a very booming field and it's not going away at all. And robotics, like I said, robotics is not ready to go for the mass audience yet, mainly because of the manufacturing things. It's expensive. Not everybody can afford a robot, but in the future is not going to be like that. Like for example, before, when the mobile phones came in the early 2000s, only the rich people could afford mobile phones. Everybody else used landline phones. Like robots is like that right now. In rich people's houses, these factories and all these expensive things, they use robots. But in the next 10 years, Who knows? Like when I was studying in college, we had button phones. And the year I graduated, like 1 year later, everybody had smartphones. Touch phones. Within one single year, something might happen so fast in this day and age. Like tomorrow, we could be having robots in our house instead of pets. So robotics is a really, really booming field in the future. Like the future, as in when we say future in the past, it's like 10, 15 years. But now, if we say future, it's like 5, 6 years. It's that fast. Healthcare, I saved it for a separate slide, mainly because it's very important with the current situation itself, Corona. We do not have any kind of complete solution for Corona. And when this disease spreads so fast, before when the last time the Corona came was in 2003, and at that time it didn't reach India, or it didn't affect that much people, because the number of people traveling from China to India or from abroad to India was very less in the early 2000s. People did not do that much because the airfares were high and everything. But now everybody is traveling like everywhere. So this is a very important lesson that we learned from the COVID pandemic, that we should be ready with healthcare in case the future something like this happens. We cannot stop people from moving from one place to another. We can't force them to wear masks. We can't force them to do restrictions because they do not obey. We know that. And we need another solution. So AI is most important in healthcare because we do not want our population wiped out by a pandemic. Maybe some other like disease might come and we might actually be like, wiped out. So this is very important. If you are able to go into this field and do some good, you will be saving lives literally without being a doctor. And mobile like when my relatives, when they had COVID, they were diagnosed and they actually everything happened with a digital consultation. They did not go actually to physical places. And we have less doctors compared to patients. The more amount of patients are there, the need for proper information, the proper medicine, the proper dose, and most people do not still understand a medical prescription because it's written by a doctor and they don't know which medicine to take where. So we need some kind of thing. Like let's just say a doctor writes a prescription and it goes into a patient's app and the patient gets reminded at the right time to take the medicine in a simple, more way, which is not like how a doctor writes his prescription. So it's easy for them to understand. A person who's like, not technically involved has difficulties. So it's a very important field, and almost new diseases are coming up, new kind of things are required, new and already existing diseases. There's a lot of population in the world who do not have access to, scanning, expensive equipment and all those things. And artificial intelligence can help them, because when you develop a system which can be applied in a mobile phone or something like that, you're helping a lot of people who do not have that much money to help themselves. Yeah, and that brings us to the end of the session. If anybody is interested in knowing more about artificial intelligence, or if you have any questions, you can drop in my LinkedIn. And if anybody has any questions, you can type them in the chat, or you can turn on your mic and ask me. And the artificial intelligence is there in almost every single field. If there is any other field which I've left out and you want to know more about it, you can ask that as well, because there is not enough time for me to cover everything. So if you have specific field which I have not covered yet, or you want to know more, or you have some questions, you can ask them in the chat. I'll be taking questions for the next 5 minutes.
Hi Kamal, this is Sudhakar.
Yes, tell me, Sudhakar.
Yeah, thanks for giving a very informative information.
Thank you.
Actually, as you told that for AI, it will be basic thing is programming, right? Programming knowledge.
Yeah.
Actually, I'm into IT from 10-15 years, but I'm into the database administration field. I doesn't know the coding and programming side. So how could myself, like in the database administration, who are not in the programming field, who are in the IT field, how can we sustain if we want to if we want to move into this artificial intelligence, because we are not aware any programming language?
Yeah, like I said before, programming itself is very required, because you can't do anything here without programming. But at the same time, new programming languages are coming up. And the thing is, before, since you say that you have 15 years of experience, when you came into the industry, you might have been seeing like everybody's like C, C++, C, C++. But now everybody's like Python, and every school, every college right now has Python in their syllabus. The reason is Python is incredibly easy. I actually delivered a small lesson on showing how easy Python is compared to the other languages. And the reason why you can learn Python even at going into 15 years into the database industry, where you worked as a database warehouser or administrator, is because that it's very simple and very it doesn't have put you strict rules like you have to follow this, you have to follow that. You can implement concepts, you can run programs. And if you want to make the leap from going from one field to another, because database itself is related to artificial intelligence, you can find the common fields for you, and then you can find out some programming languages. I would suggest Python, because since you say that you don't have anybody who is not uh, a full-fledged programmer should always go for Python, because it's incredibly easy to pick up. And once you get the basics, you will be having, you might be seeing like how easy it is, that, and you are just afraid of nothing. So if you can learn Python, and most of the Python workshops are there. They are only one day. So if you go in morning, you can come out in the evening learning Python. I've conducted Python workshops in colleges before the COVID, not now. And yeah, I've been able to train people in Python in a single day. So if you want to take a leap like that, a single day is all it will be required for you to learn a programming language and get into it. Okay, hope that answered your question. So yeah,
Yes,
if
yes.
you could go through
Yeah,
about.
thanks. Yeah, thank you.
Okay, so do we have any more questions? Any more questions about careers, opportunities, and okay, I'll wait for another minute, and if you have no questions, I'm closing the session. Okay, I think we don't